So number 5, the function is x over x squared minus 3. And again, if you're going to graph these so that you can, or if you get one similar to this, and you want to see the domain and range, because of course the graph really helps. Remember to parenthesize the denominator here, because if there's more than one term, if it's got like a coefficient or something being added or whatever, just to be safe, even if you want to put the numerator in parentheses, but you really don't have to, because see how it's a single term. But anyway, just to be safe, make sure you have the entire denominator here put in parentheses, otherwise it's not going to graph correctly. So that graph is really weird. It's got 3 branches, right? It's got one down the center there, and it's got 2 branches in opposite quadrants that basically look like hyperbolas, right? So our domain, when we think about domain, remember, we're thinking about left to right, the values that we're not able to put into our function. Well, if you look right here, we have a vertical asymptote, and you look right here, we have a vertical asymptote. So there's actually 2 numbers that are eliminated from the possible inputs. And again, remember where that comes from is by looking at the denominator and see what would make it equal to 0. Because then you can't divide by 0, make it undefined. So I'm going to add 3 to this little equation. I'm going to set it equal to 0 and then add 3. And then I'm going to take the square root of both sides, which when I square root both sides, I end up with a plus or minus the square root of 3. So if you want to be really exact, you could just leave it as a square root of 3 and negative square root of 3. So you've got one of these asymptotes is that x equals negative square root of 3, and the other one is x equals square root of 3. So those are the 2 values you want to eliminate for your domain. And when you have to use interval notation to do that, that means we're going to have 3 separate intervals. Okay, and you can see there's 3 different sections of the graph. So from negative infinity up to, but not including, negative square root of 3, right? So again, parentheses on both. Then union with, then between, so we're in here, right here, between negative square root of 3 and positive square root of 3. And then finally, we'd have to add into that past the square root of 3, positive square root of 3. So square root of 3 up to positive infinity. So that's what the domain would look like. Okay. Now the range, if you look high to low, and if you also, you kind of compare your numerator to denominator, actually looking high to low on this, it actually looks like it might be all real numbers. It doesn't look like there's a break horizontally, right? But in fact, I know that there's a horizontal asymptote because remember when you compare higher power on the top, which is 1, right? Oops, there's a 1 there, right? And the highest power on the bottom is 2. When the higher power is on the bottom, there's actually a horizontal asymptote at y equals 0, okay? I know it doesn't look like it because it actually looks like the graph crosses through it right there, right? And I know that's kind of confusing. That's just kind of a weird anomaly. It's almost like it's kind of coming up to the y-axis, or x-axis, excuse me, at y equals 0, and it's kind of just jumping over and continuing on. So technically there is a horizontal asymptote, which means that's the one value that can't be in the range. So that means my range is negative infinity up to, but not including 0, and then after 0 up to positive infinity. So number 6, we want to know the domain and range of g of x is equal to x squared minus 4. Well, remember I said quadratic functions, which is what this is. Domains always are real numbers. So that just means negative infinity up to infinity for your domain. Okay? Again, left to right, this graph goes on forever. Now the range, though, remember that has to do with where the vertex is. And the vertex is right there. Oops. And if you kind of just look at the equation, you can tell that this is just a regular parabola shifted down 4, which means that vertex right there is at 0, negative 4, right? And so that is actually the lowest y value that this graph has. So the lowest is negative 4, and it does include it, right? So we want to, because you can tell that point's actually sitting right at negative 4, and then up to positive infinity. Okay. And in fact, while we're doing that one, let's go ahead and take a look at number 6, because that's also a quadratic function. So your domain is going to be all real numbers in negative infinity up to infinity, right? But then your range here, now this parabola opens down, right? So this happens to be a parabola that's flipped over, reflected over the x-axis, right? And then shifted up. Like this is up 3, right? So that point, that vertex is at 0, 3, but then the thing's facing down. So in fact, the 3 is actually the highest value that y ever has. So your range is going to be negative infinity up to the highest point it would get to is 3, and it's included. Okay. Number 7, when I graphed it, it looks like this. It looks like just maybe one of the branches from a hyperbola. Okay, so you can clearly see that there are some places where this graph doesn't exist. It doesn't exist down here. So when you think about your range, okay, that's going to be, it's not going to be all real numbers, right? And then the domain does not exist over here, right? So we just got to figure out where does this thing cut off and what is not included. So remember when we want to find the domain for something like this, we want to see, it looks like there's a vertical asymptote. So we just got to figure out where is that vertical asymptote. So, and we know we can always look at the denominator for vertical asymptotes and see what makes it 0. Well, this time it's a little more complicated to figure out, right? Because it's the square root of x minus 3 is equal to 0. That's what we know. That's where the asymptote would be. So what would make that 0? Well, in order to figure out what would make that equal to 0, I'd have to think about what would x have to be so that when I subtract 3 from it and take the square root, I get 0. Well, of course, x would have to be 3, right? Because 3 minus 3 is 0. The square root of 0 is 0. Okay, so that's the value that would make this undefined. So that's where your vertical asymptote is right there at x equals 3. But then the graph doesn't continue on to the left of it, right? That's just the cutoff point. So the domain actually starts just after 3, okay, and goes to positive infinity. Because it goes all the way to the right forever like that, right? Now your range, high to low, it looks like it's starting to taper off right about in here, right? So there appears to be a horizontal asymptote. And there actually is a horizontal asymptote here, and it's the reason why I know it's at y equals 0. There's actually one right here, right at the x-axis, right at y equals 0. And how I know that is, remember the higher power is on the bottom? In fact, the power on the numerator is 0, right? The power on the bottom, actually, that is actually going to be higher, even though it's, no. Okay, it's because the numerator is 0, so the power on the bottom has to be higher. So that's why it's at y equals 0. So that is actually the value that is the lowest in this case that the graph ever gets to, because it doesn't continue on after. It's not down here anywhere, right? It's only just above that. So it'd be above 0. So 0 is our lowest value. Our highest value is positive infinity. Okay. Now remember, when there's asymptotes there, we can't include that line that it's approaching, right? So it's just higher than 0, but continues above forever. Okay, so here are the last 2 questions for domain and range. And I've graphed them. And so when you graph these, again, you got to make sure you parenthesize the numerator and the denominator. This is how I got the graph to look the way it's supposed to look. And this graph, you can tell, looks like a hyperbola again. It looks like it's got those 2 separate branches. I see the break in the graph from left to right, okay? And I see a break in the graph from high to low, which is where there would be a horizontal asymptote. So we got this kind of hyperbola looking thing. And so our domain, it's to the right forever, starting at where that vertical asymptote is, and then to the left forever, it goes down here, right? But the one place it does not exist is where that vertical asymptote is. So remember, the vertical asymptote comes from what makes the denominator 0. So we just have to set that denominator equal to 0 to figure out where that vertical asymptote is. And again, that is going to be the thing that's eliminated from the domain, right? So we would have to add 1 and divide by 2. So in other words, this asymptote is at x equals 1/2. Okay, so that's the one value that's not in the domain. So we have have a domain of negative infinity up to a half, but not including either one, right? Can include the half because it's where the asymptote is. And then starting after a half and going up to positive infinity. Okay. Sorry, the dogs are making so much noise. Now the range, high to low. Okay. There's a horizontal asymptote right here. Now, it might actually look like it's at 0, like at the x-axis, y equals 0. But in fact, we know that the horizontal asymptote is going to come from comparing the coefficient of the numerator and denominator here, because they're both, the top and bottom are to the power of 1. So if we look at the coefficients of the numerator, highest power, and the denominator's highest power, that's going to tell us what the horizontal asymptote is. And it's going to be at y equals, we've got a 1 on the top and a 2 on the bottom. So it's actually at y equals a half. That's that value right here. So it's actually splitting the graph at a y equals a half. So that's the one value that's not in the range. So it's going to include up to 1/2, but not including a half, and then 1/2 and up to positive infinity. Okay. So that would be our range. Now the final one, y equals negative x over the square root of x plus 3. This is what the graph looks like. So this is what the graph of the function looks like. And I can clearly see the graph sort of begins right here, and there's appears to be a vertical asymptote. So where would the vertical asymptote would be is where that denominator, right, when it is actually has to be greater than 0, okay? It can't be equal to 0. So what we have, because again, it's on the denominator, so we have to think about what would make this be a number that's greater than 0, because it can't equal 0, okay? And so if I put -3 in there, right, for x, that's going to give me the square root of 0, which is 0. So we can't really include -3, but we could say the domain actually is going to start just after -3. So that's how we just say not to include it. And then it's going this way forever to the right. So positive infinity. Okay. And the range, not positive. You might want to check with him about this. But the range, he said it was negative infinity to infinity. And I'm not 100% sure why that is, although I guess it looks like it's not tapering off down here towards any kind of horizontal asymptote. And the higher power is on the top, because this is really kind of like saying x to the 1/2 power, right? So this is really x to the first on the top. So the higher power is on the top. So technically there's not supposed to be a horizontal asymptote. And so it's because there's no horizontal asymptote. So that's really why it's in negative infinity to infinity, because technically this thing is going to keep going down and down and lower and lower and lower as you get out further to the right, okay? And then to the left, it's going towards positive infinity. So it's easy to see why it would get, very, very large, but to see how it gets very, very small for the y's, that's a little more difficult to see. So that does it for those problems.